so let me just share my screen. Hey, so can you guys see my screen now?
Yes, sir.
Yes, sir.
Okay, so I have just announced a while ago that, oops. So I've just updated the module one. Actually, the other one is the same with the updated one. It's just that in here I have added some pictures. Okay, and then maybe I've emphasized this one a little bit more by putting some more colors or by highlighting some more of the text. Like for example, this one home appliances is composed of refrigerators, televisions, lamp, etc., etc. So again, with a picture of the person who founded or created or invented the Ohm's law, okay, George Simon Ohm. And I guess with more pictures, okay, and then with more emphasis of the labels, okay, and then I guess it's okay. So maybe I've just added another picture. So maybe you are wondering why I can't remember the things that I have added, because the one that I have uh, uploaded before, the very first module one that you have before is the one that I've used 1 year ago. Okay, and then the one that you are seeing right now is the one that I've discussed last sem. Okay, so that is the reason why I can't remember the things that I have changed in here. Okay, but anyway, this is the updated one. Okay, so yeah, it's more larger text and more clearer. Okay, and then picture of the person who invented or who found out the uh, the computation about HP or horsepower, James Watt. And yeah, more pictures. Okay, and then more pictures. Okay, and then this is where we've stopped last meeting. Example number 5. All right, am I correct? So are we able to answer this one last meeting? Example number 5, or not yet? Anyone from the class who can recall or remember where did we stop last meeting? Late and Raleigh, sir. Okay. How about you, Miss J. Ventura? I'm sure that you are here last meeting. Can you still remember where did we stop last meeting?
I think we stopped at example number 4, sir.
Number 4. So number 5 is not yet finished. Okay then, so let us answer this one. Okay, so an electric motor drives a mechanical, okay, gilid ko lang tong picture natin. So an electrical drives a mechanical load taking 18.8 amps from a 230 volt source. So here are the questions. Calculate the power input to the motor. Letter B, the horsepower output if it operates at an efficiency of 86.4%. Okay, so from here, it is asking us to solve the power. So again, the formula of our power is equal to P equals to I times I. Okay, P is the power, and then E is the voltage source, and then I is the current. So in here, voltage is already given, the voltage source, and then the current is also already given. So we can use this formula right away. So E is equal to 230 times I is 18.8 amps. Okay, so just do the math, and then you'll be able to get 4,320 watts. Okay, so as easy as that. Okay. And then for the letter B, the horsepower output if it operates at an efficiency of 86.4%. So in here, you have to get the 86.4% of this one. So just multiply this one by 86.4, I mean 0.864, just like this, okay? And then divide it by 746 because uh, 1 HP is equal to 746 horsepower, okay? Going back to our formula right here, 746 watts rather, okay? So 1 HP is equal to 746 watts. So for you to be able to get the HP equivalent, so you have to divide this one by 746. So again, just get the 86.4% of the total power and then divided by 746, and then you will get 5 horsepower. Okay, horsepower output. Okay, so as simple as that for the example number 5. So were you guys able to follow? Is this clear so far? Example number 5.
Yes, sir.
Okay, so anyone who's confused? So to those who have just enrolled uh, quite late already, so just read the slide 1 to 25, and then you'll be able to understand what we are discussing right now. Okay, so yeah, I guess you can do those by doing some sub study, since those are super simple for now. And if there are parts of this module that you cannot understand, so feel free to ask me anytime. Okay, so you can message me to my Facebook account, or you can message me to my Canvas. Okay. All right, so for the next one, example number 6, what is the resistance of a load that takes 2,500 watts from a 115 volt source? So in here, resistance is the one that is now being given, and then the voltage source. So from here, we can use the formula. Oops, crap. Ayan naman. Okay, so from there, we can use the formula P is equal to E squared divided by R. Okay, so in here, sorry, the resistance. The question is, here is the resistance, not the resistance is the one that's being given. So in here, the power is the one that is being given, and then the voltage source. So you can just interchange those two or cross multiply, and then you'll be able to get this formula. R is equal to E squared divided by P. Okay, from this original formula of P is equal to E squared divided by R. So E is 2,500 squared divided by, oops, tama ba? Hindi. Baliktad na naman. Okay, so E or voltage source is 115. And then P, tama ba? Yeah, tama. So this one is squared. And then P here is 2,500. Okay. So just use your calculator and you will be able to get 5.29 ohms. Okay. Okay, so that's how simple example number 6 is. So were you guys able to follow?
Yes.
Okay, so
Yes,
again,
sir.
this formula originated from, so ulitin ko lang para sa mga hindi nakasunod dati, sa mga huli. So our original formula is actually P is equal to IB. But then again, we have this Ohm's law formula, V is equal to IR, wherein V can be replaced by this formula IR. So we can also have I times IR, wherein if you're going to simplify this one a little bit more, this one will become I squared times R. Okay, so this is, let's say, your first formula, and then another formula for computing P. And then we can also have another formula wherein you can replace this letter I right here, or your current, wherein I is equal to V divided by R. Okay, so just replace this I by this formula, and then you'll be able to get V divided by R times V. Okay, wherein if you're going to simplify this one a little bit more, this one will become V squared divided by R. So again, V is the same with E. Sometimes it's being represented by the word EMF. So those three are just the same. They are representing the voltage source. So V is for the voltage. So sometimes you have VS right here, which is stands for voltage source. So voltage, E is for the battery, and then EMF is for the electromotive force, and Vs is for the voltage source. Okay, so those four are just the same. Okay, so again, this is another formula wherein we have P is equal to V squared divided by R, or E squared divided by R. Okay, so we have those three formulas. So those three are just the same with each other, just a different usage of variables, or given variable. Okay, so I hope we are clear with this one. So for the next one, we have electrical energy, or electric energy. Okay, so since power is the time rate of doing work, so sometimes stated as the rate of expenditure of energy. So it should be clear that electric energy is the product of power, or watts, and time. So yeah, we could say that P is equal to energy, okay, times time. Okay, so for you to be able to get or develop or create an energy, so it grows over time. Okay, so we have this a constant value of power, but for the energy, so it's depending on the time that you will spend, on how long or how short you're going to spend that power. Okay, or how long you're going to use that power. Okay, so of course, the longer the usage of power, the more heat that you will be able to uh, accommodate, or have or release in that appliances, wherein it would this heat will lead to power loss. Okay, so basically it originated from the power, and then if you have energy, this will generate heat, and then that heat will become a power loss if that heat is not really useful in that appliances. So like for example, in our monitor, so it generates heat, wherein we cannot really really use where is that heat for. So in that case, that is a power loss. However, in some appliances like a heater, a water heater, so the role of that appliance is to generate heat, wherein of course this power loss, or this heat right here, will not become a power loss, wherein it will become useful. Okay, so yeah, that's how we identify if that heat is a power loss or no. All right, so anyway, we have this formula right here for the watts is equal to power times time, or equals to voltage times current times time, or you can have I squared times R times time, or you can have E squared divided by R times time, joules. So all of those are the same with each other. Okay, so just remember that for you to be able to have a energy, just multiply this one by time, power times time. Okay, so let's have an example for this one. Before that, okay, so again, we have kilowatts, right? or watt for now. Okay, so let's start with watts. So originally, we have 1 watt is equal to 1 HP. Okay, so if you will make this one into kilowatts, so just multiply both sides or by both equation by 1,000. So this one will become 1 kilowatt is equal to 1 kilowatt per hour. 1 kilowatt per hour. 1 HP. Tama ba? Horsepower. Okay, just let's remove the horse na lang para consistent tayo. Let's just use power. 1 power. Okay. So, in here, if you're going to have a 1,000, okay, so this one will be read as 1 kilowatt per hour. Okay. And then this one will become 1 power divided by 1,000. Actually, ito rin pares lang din siya, 1 kilowatt per hour. Okay, pero mostly sinasabi lang nilang 1 kilowatt. But in here, on the other side, you have to multiply this one by 1,000 for you to be have a 1 kilowatt per hour. So dito parang invisible lang. So 1 power divided by 1,000. Okay? So since this one is energy, so you have to multiply this one by time. Okay, or mostly the time in here is in a form of hour. Okay, so that is why we have 1 kilowatt per hour. Okay, is equal to 1 power times hour divided by 1,000. Okay, which is the same with this one. So nilagay ko lang yung 1 power pero kahit P times hour na lang yan. Okay, para mas simple. Okay. So dito, kilowatt per hour, which is, divided by 1,000, it's eto na yan. Okay. So, nagets nyo ba so far? Kung paano natin nakuha tong kilowatt hour na to. Okay. So, again, ulitin ko, kilowatt per hour talaga to. Okay. Pero nakasanayan lang kasi natin sa world ng electricity na parang kilowatt hour na lang. Okay. Kaya, ang ginawa dito, parang 1 kilowatt na lang, parang invisible yung hour sa baba. Okay. Kaya, baka nalilito kayo bakit kilowatt hour lang dito, pero dito is divided by 1,000 na. Basta ganun. Okay, kung nalilito kayo, pwedeng sabihin yung kilowatt per hour to, yung basa neto, or kilowatt hour, wherein it is the same with P times hour divided by 1,000. Okay. So, I hope hindi kayo masyadong ma-confuse kung bakit ganito. Kung bakit kilowatt hour lang, kung hindi kilowatt per hour. Anyway, so yeah, this is the formula for the kilowatt hour. So, meron tayong P times hour divided by 1,000. So, let's have an example for this one. So, how much electric energy in kilowatt hours is delivered to an electric motor during an 8-hour period when operating from a constant 230 volt source? So, if the average currents are 34 amp for 2 hour, and then 38 amp for 1.5 hour, and then 26 amp for 4 hour, and then 12 amp for 1/2 hour. Okay, so as you guys can see, we have 4 appliances wherein all of them consumes a total of 8 hours. So 2 hours plus 1.5 hour is 3.5, plus 4 is 7.5, and then lastly 1/2 plus 1/2 is equal to 8 hour in total. So in here, just get the summation of this one, okay, with the use of the formula IV, okay, or P is equal to IV. Okay, and then of course, you have to multiply that one by hour since we are getting the electric energy. So, basically, same lang naman lahat. Okay, from before, we have the current, which is 34, and then the voltage, which is 230. But in here, so kagaya ng sabi ko kanina, i-multiply nyo lang sa time, okay, or hour, which is 2 hours for this appliance. and then 1.5 hour for the second appliance, and then 4 hours for the third appliance, and 0.5 hour for the last device or last appliance. Okay, and then you have to divide the summation or the total submitted power by 1,000 for you to be able to get the kilowatt hour. Alright, so ganun lang naman siya kasimple. Gamitin niya lang mismo tong formula na to, and then you'll be able to get this result right here. Okay, so voltage source is already given, and then we have a total of 8 hour right here, which is already given by the 4 appliances. And then just by using this formula and then doing the math, you'll be able to get 54.05 kilowatt hour. So, nakasunod so far?
Mhm.
Yes, Mr. Labsan?
Gets naman sir, pero yun nga, yung parang kanina, yung kilowatt per hour lang dun lang nalito siguro.
Okay. Anyway, so para siguro ma-avoid yung confusion dito, memorize na lang kung ano yung meron dito sa kabila. Okay. So for the kilowatt hour, actually nag-umpisa tayo sa 1 watt, right? So 1 watt is equal to 1 power. So 1:1 naman lagi yun eh. So just multiply both sides by hour. Okay. So which is you will be able to get this hour right here. But then again, for the 1,000, para kasi 'di ba kinukuha natin yung kilowatt. Okay? So 1 kilo is equivalent to 1,000 power, parang ganun. Pero paano nga ba na-derive? Okay. So balikan natin. Kasi kahit ako nalilito kung bakit naging ganun. So if you will make this 1 kilowatt, okay, you'll basically multiply both sides by 1,000. Okay, since they are 1:1. So this one will become 1 kilowatt, and this one will become 1,000 power. Okay. And then since we have, kapag sinasabi nating energy, just multiply this power to time. Okay? So ang kinukuha natin sa right side is the energy itself. So just multiply this one by hour. So kapag nagkaroon ka ng hour dito, so of course you have to multiply on the other side hour also, in which you will have 1 kilowatt hour is equal to 1,000 P times hour na. Okay? Kaya hindi ko na alam kung paano nangyari yung 1 kilowatt per hour dito, which is supposedly 1 power times hour is equal to 1 kilowatt. Alright, so this will serve as my assignment. Okay, since hindi ko inalam yung derivation, kung paano natin nakuha itong formula na to. Okay, so balikan natin to next meeting. Kasi ang inalam ko lang talaga, ang equivalent ng 1 kilowatt is, just divide the energy by 1,000. Alright? Hello guys. Okay ba kayo doon? Assignment ko na lang to.
Yes, sir. Thank you po.
Yes, sir. Okay lang.
Kasi hindi ko na talaga inalam, okay? Ang mahalaga lang sa akin noon, actually until now, okay, is etong formula na to for the energy, okay? Just multiply that one by, the time. And then if you want to get the kilowatt, just divide it by 1,000. And then that's it. Pero sige, alamin natin kung paano ba yung derivation nito, which we'll discuss next meeting. But for now, okay, just answer this number 8 or example number 8 for now. So this will serve as your assignment number 1. So a water heater has a resistance of 5.3 ohms and takes 43.5 amp when in operation. So if it is in service on the average of 2 hours per day, how many kilowatt hours of energy will be expanded during a 30-day month? Okay. So I'll leave the understanding part to you guys. So basta ang goal nyo dito is malaman kung ilang kilowatt hours. Okay, which is I think very, very familiar with this one. Okay, just by having this formula, you'll be able to answer example number 8. Okay, so last one is heat energy. So like I have mentioned a while ago, kapag meron tayong energy, okay, over time, so kapag mas matagal mong ginagamit yung energy na yon or yung power na yon, of course, it generates heat. Okay? So, naka-convert yung iba doon into heat. So, sometimes, kapag hindi natin kailangan yung heat talaga na yun, okay, so, tinatawag natin yung energy loss. Okay? Or yung mga tinatawag nating tawag dito, necessary heat, kumbaga. Kasi yun yung, just imagine this one. Kapag yung isang pot, walang resistance, okay, so pwedeng sumabog mo, overload. Actually, yung resistance mismo na yun, doon na-generate yung heat. Okay, kaya nga kapag nakahawak kayo ng resistor na running yung isang circuit, okay, or yung isang device, kapag hinawakan yung resistor, sobrang init nun. Kasi doon, parang na-convert yung ibang energy, okay, into heat. So parang ganun yung ginagawa niya kung paano niya napipigilan yung electricity or yung energy na dumadaloy sa isang path or circuit. Okay? But of course, on the other hand, kapag useful na mismo yung heat na yon, okay, like for example, water heaters, toasters, percolators, flat irons, etc., etc., as long as napapakinabangan natin yung heat. So hindi na siya power loss. Okay? So doon na siya nagiging useful. Alright? So yun lang naman when it comes to heat energy. And for you to be able to solve for the heat energy, so since the power loss is assumed to take place at a current I through a resistance R, so it is designated as an I squared R loss or briefly I squared times R. So ito mismo yung pinaka-formula natin to solve the heat energy. Okay? So for example, that's in a transmission line having a resistance of 0.03 ohm. So ito na mismo yung parang resistance na ginagamit sa isang, let's say, sa device na yon. Okay? And then it has a current of 150 amp. Okay? So ito naman yung current na dumadaloy sa mismong device na yun or circuit na yun. Okay? So of course, the larger the current, the more heat that it will generate. Okay? And also the larger the resistance, the more heat that it will also generate. Okay, so in here, if you want to solve for the energy or heat energy, so the power loss will be 150 squared times 0.03. So gamitin lang natin tong formula na to, I squared times R. And then you'll be able to get the power or the heat energy of that one, which is 675 watts. So kapag hindi useful yung heat na yon, this is already a power loss. Okay? Sabihin na natin, binabayaran natin itong kuryente na to, itong 675 watts na to, without us being, maximizing or hindi naman natin to napakinabangan, kumbaga. Pero kung napakinabangan naman natin yung heat na to, na na-generate na to, let's say, flat irons, water heater, then this one now is not a waste or a power loss. Okay, so are we clear? So we're on how to solve for the heat energy.
Yes, sir.
Alright, so ito lang naman yung kailangan yung tandaan for heat energy. Okay, which is actually the same with, power. Wala namang pinagkaiba. And for the electric energy, okay, so it is applied to useful heating such as a hot water heater. It is desirable to know how many gram calories or British thermal units. So meron tayong ibang tawag dito for the electric energy or yung heat energy or yung heat loss na tinatawag natin, which is in a term of BTU, okay, or British thermal units. So, ito na yung gagamitin nating pinaka-name if we are really solving for the heat energy is equal to, let's say, 1 grams of water. Okay? So, sabihin na natin 1:1 kasi yan. So, 1 BTU, okay, is equal to 1 gram calories. So, nasa na nga ba yun? Ito. Punta muna tayo sa note. So, let's say 1 gram calorie is the heat required to raise temperature of 1 gram of water or 1 degree Celsius. So, kung meron kayong 1,000 grams ng water, okay, let's say, sa drum nyo or sa kung saan man yan nakalagay, okay, you also need 1,000 BTU, okay, para mapainit nyo yung tubig na yun. Okay, let's say, into a certain degree Celsius. Kasi kung kulang yon, syempre, hindi nyo ma-reach yung parang pinaka-peak temperature na gusto nyong ipainit sa tubig na yan. Okay? Well, of course, kapag apoy na talaga, so sobrang taas na nun. Okay? Pero ito kasing 1 gram calorie nito or yung BTU is being, being generated by a resistance or yung current at saka yung resistance natin. Okay? So anyway, so precisely performed experiments have shown that 1 watt second of electric energy is 1 joule. So 1:1, wherein 1 joule is equivalent to 0.24 gram calories. So just by applying this conversion unit to equation number 14, so you have to multiply this 0.24 in all of your formulas actually. Kasi nga 1:1, wherein 1 joule is also equal to 0.24. Okay? So kung gusto nyo makuha yung heat for that, specific energy, just multiply this one by 0.24, or pwedeng itong P na to is 0.24 EI, okay, or pwede rin 0.24 I squared R, okay, or 0.24 E squared divided by R. So, nanggaling lang naman siya dito. Okay, so lahat yan, minultiply lang natin by 0.24, wherein we are now solving for the BTU, okay, or British Thermal Units. Okay, wherein the same lang yan sa heat energy na tinatawag natin kanina. Okay, so again, 1 BTU is the heat required to raise the temperature of 1 pounds of water 1 degrees Fahrenheit. So, hindi na ako naglagay ng example dito since same lang naman siya sa lahat. It's just that you have to multiply that one by 0.24. So, kapag tinanong doon, ilan yung nako-consume niyang or ilan yung equivalent British thermal units. So just multiply the power or the heat energy by 0.24 and then that's already the answer. Okay? Wherein ang label na pala nun, bago ko makalimutan, ang label na nun mismo is calories. Okay? Or gram calories. Okay, so yun lang naman for heat energy. Okay? So yeah, that's it for the module 1. So are we clear so far?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay, so wala na tayong oras. So mag-meet na lang tayo for the module 2 later on.